Okay, hello, Link341. Welcome to another lesson. Today we are going to talk about fricatives. Um, so our goal is to go through the fricatives of the world and inspect some of their properties, right? Um, that brings us again to our source filter theory, right? So far, we've considered the following source filter configuration: source as the voicing of your vocal folds, and filter the resonation or resonating of your vocal tract, right? What would happen if we changed the source by opening the glottis, that is not voicing, and increasing airflow so that there is some audible turbulence as the air passes through the vocal folds? So what would happen then? Imagine opening your glottis and increasing the airflow, right? And start talking like that. So I will share this with you. We get something that we call whispering. So we would talk like this. This is whispering, and I'm not voicing at all. I'm just opening and closing the glottis by pushing the air, or actually, I am opening the glottis and increasing the airflow right through my lungs, and by pushing the air, I am whispering. Right, so that was whispering. And these two are whispering examples of had. So this one is actually the whispering example of had, and this one is the voiced example of had. Let's listen to those.
Had. Had. Had.
Right? So these two are different in that here you can clearly see formant frequencies, right? First of all, um, but more importantly, you can see what we call voicing bars, right? Remember, glottal pulses or voicing bar, each individual uh, vertical sort of bar is voicing bar, and we can see them here very clearly because there is a lot of voicing. Here there are no voicing bars on this display, right? And what's typical of her as a whispering example, and her as well, is that the formant frequencies are basically the same at the same level, or almost similar level to those that occur in the voiced example. And you can clearly see here "h" as a noise, some kind of a noise, right? And here it's "h" sort of all the way through "had," right? So it's whispered, and it creates a noise that we will talk about, which we call fricative noise, right? Okay, so um, this would be a whispered "had," right? The sound source of whispering is the turbulence that airflow creates as it passes through the vocal folds. So basically, now with fricatives, we have a different source. It's these are not it's not voicing anymore. It's not vocal folds anymore. We have glottal, not glottal. We have fricatives, which are noisy, and they are aperiodic, which we will see later, in comparison to vowels, have which are periodic or quasi-periodic in reality, right? But they have certain pattern, and the source of vowels is the glottis or vocal folds, right? Um, this one is h is glottal fricative. The IPLE lists two sounds as glottal fricatives. The first one is the second one is right? It's voiced. So that's the only difference between the two. The filter of both sounds is the same vocal tract shapes that we find in vowels, and that's um, quite nice. That's why sometimes Peter Ladefoged produces h like heed, hood, hod, right? Because these here formant frequencies, or maybe not those. Let me, yeah, with h are the same as the formant frequencies for vowels, right? For the vowel part, okay? And uh, that's why it's very neat to use h like heed, hood, hod, right? When you're producing these, because the formants do not go up or down if they are influenced by a consonant. In this case, the consonant would be h, right? Like a glottal fricative. So in a sense, h is a voiceless vowel, right? And h here is produced in different vowel contexts, such as
heed,
heed,
had,
right? And yeah, you can see here that e or h in this case, which is noise, right? All h has the same resonating frequencies like f3, right? Here, f2. There is some kind of energy there, and there is not a lot of intensity in the f1. Here as well, some intensity here, some intensity here, and intensity here, because it has the same formant frequencies as vowels, right? And I want to play these, which are you cannot hear, right? So it follows basically when you extract the h part, it almost you can sense just based on this part, this little chunk here, which one we are producing. He, right? Right? Because the filter or formant frequencies are the same as for the vowels that are following this little glottal fricative, right? This is h in different vowel contexts.
hood,
Hood and
hod,
hard, right? And you can now feel it. Listen to this one, right? So it has the same formant frequencies, and that's why we call it a voiceless vowel in a sense. But it is a glottal fricative, and you should remember that. In English, h often surfaces as breathy voiced h when it appears between two vowels. So it would be
ahead,
ahead, right? It would be here. And again, as I say, look at the formant frequencies. They're basically not changing because the next vowel is a, right? So they're following those formant frequencies, and this is
head,
head, right? A voiceless version of this one. So we have voiced and voiceless. However, the sources are not glottal folds anymore. They are just vibrating or not vibrating in this case. In the second case, actually, and we get a glottal fricative. Okay. So the source of fricative sounds is aerodynamic turbulence, and we call this turbulence aperiodic. Aperiodic and random. Aperiodic sounds are noisy, and aperiodic sounds differ from periodic sounds. And let me show you. For example, I will make maybe okay, I think it saved it. So this would be right, and see this noise here. Let me increase it a little bit more. So it's completely random. It's random. The frequencies are all over the place from 0 to or whichever frequency this prod captured. And here, the intensity is quite high, but look at the waveform. These are periodic complex waves, but still periodic, right? They repeat themselves in certain pattern, and for fricatives, they are completely aperiodic, right? Some kind of noise. See, right? Okay, so aperiodic sounds are noisy. Their pressure values vary randomly over time. This is a waveform snippet of aperiodic sound that we can, sorry about that, that we can call white noise, right? You've heard about white noise, right? It's analogous to white light. That's what you get when you combine all visible frequencies of the electromagnetic spectrum. White noise is called so because it has an unlimited range of frequency components, meaning that this is how its spectrum looks like, and there is an unlimited range of frequency components. So from 0 to who knows what, right? And oops, sorry again. And these are this is white noise that we hear here and there in for example, in old TVs, if you've seen some of those, or in some TV shows that they showed old TVs, right? Usually what we hear in the background, for example, when fans are on or fridge is on, it's what we call pink noise. It has much lower intensity in certain frequencies, so it's much more you feel much more comfortable when you're listening to that noise instead of white noise, right? And this is a white noise spectrum. I showed you my own, right? Sort of white noise, which was a fricative. And this is I think it's actually white noise that has been generated by computers, so it's ideal white noise, right? Less ideal would be something like a fricative. And a very important so it has random intensity at all frequencies. There is no form and frequencies that are more intense, right? That are amplified. And an important thing is the sound source of fricatives resembles white noise, right? But this aperiodic noise may be filtered by the vocal tract in the same way that voiced vowels are. For example, you might have this white noise as your source, or just noise, but you shape your vocal tract by saying s, s, f, sh, right? And by shaping it, certain frequencies still get more amplified than others, and that's what makes them fricatives. That's what makes them different, right? So h tends to take on the spectral characteristics of the surrounding vowels. That's why it's such good great consonant for producing vowels. H just replaces the voicing source with an aperiodic sound source, right? And we know of co-articulation, that basically even co-articulation, like here, had it is voiced, but still it takes upon itself these formant frequencies of a following vowel, right? Okay, right. So we've covered that, and now we can move forward actually to sound fricatives of the world. So we know that now the source is a little bit different, or different from vowels source. We know that filter is also different because we're shaping our vocal tract, and this is what we can produce. There's so many fricatives in the world. I think fricatives are among I think fricatives are the greatest in number of all IPA sounds, and these are fricatives in your IPA chart. I think there are a couple of more fricatives, such as hu, right? Sorry, that we had for your for midterm, right? Fricative's place of articulation is where the vocal tract in the vocal tract where the turbulence noise is made, and that's very important. So it can be fronter, it can be towards the back, and we'll see these in our next class. In those ones in the middle, we'll focus now on those ones in the back and maybe the frontal ones. At different places of articulation, fricatives will have different filters based on the area and shape of the vocal tract in front of the obstruction of airflow. Right, so you have some sort of airflow running through your vocal folds and going through your vocal tract, and you shape it, right? You place the tongue high or low, you place it close to the palate, you place it close to the post alveolar ridge, right, and so on and so forth, and you make some kind of a channel, right? So you will produce different sounds. You can also make fricatives into the back, right, in the back of your throat, and there are different sound sources based on the flow of air through the obstruction, and because of these different sound sources, the acoustics of fricatives will look differently. Right. Okay. We will start first with our glottal, epiglottal, and pharyngeal fricatives. We've already covered glottal fricatives, which were h, actually and right? So voiceless and voiced glottal fricative. The ones that you use in English, especially the voiceless one. The next one is epiglottal or are epiglottal fricatives. Epiglottal fricatives are made by constricting this area here with your epiglottis, right, and making turbulence here, right? So it does not touch, epiglottis does not touch the pharyngeal wall, but it's close enough, right, to make this channel, small channel where the sound travels, or not sound, air travels, right? Making it a source, okay? And pharyngeal fricatives are made by placing the root of your tongue back towards the pharyngeal wall. All right, let's see what these are. So these are glottal fricatives produced by Ladefoged. Yeah. A voiceless one is better when it's in initial, right? Like had. This is voice one for sure. And these are two epiglottal fricatives. It's like a capital H and a shepherd's hook. So question mark to the other side and a line striking it through. Right? And these are pharyngeal fricatives. Right? So the voiced one is just without this strike through mark. And this one is a weird looking one. We have it in Cyrillic alphabet. I don't know why they are using it in the IPA, to be honest, but it's just a convention. I guess most of these appear in Caucasian languages. So some are like maybe they took it from Georgia or somewhere there, but this is just my assumption. All right, so this one sounds like this. Right, and these fricatives are quite common in Arabic. And Arabic is a language that is spoken all around the world, so you will hear those, and some of you might know how to produce it, right? These ones are less common, but they are produced in the Caucasian area, or Caucasus area of Europe and Asia, right? So between Europe and Asia, that part. So try not to confuse the symbols for the voiced epiglottal fricative, which is this one, and voiceless epiglottal stop, which is this one. So it just turned to differently, right, towards left, and this one is turned towards the right. So try not to confuse them, although you will not use them very often. And also note and also not note the symbols for the note the symbols for the voice pharyngeal fricatives, fricative, which is this one, and glottal stop, which is this one. So try not to confuse these two as well. Okay. How can you produce these? Well, one of the things that you can do is basically produce a glottal fricative, like, and try to increase the intensity. So try to increase the intensity of the airflow running through your glottis. And if you want to voice it like I just did, like voice it. Actually, yesterday, quite by accident, a student at the University of Calgary came to our office and asked me to warm up his lunch because we had a microwave. And I asked him about his name. He said his name was Amir. And he said, "Oh, we have those sounds in the back of the throat, blah blah blah." And I said, "Is that this sound?" And he said, "Yeah, that's the sound, right?" Allah, right, Amir. So I told him what I teach and that I will be teaching you today the sounds, and that's a true story. So you get to encounter these in real life, right? Okay. So our examples of glottals, epiglottals, and pharyngeals are here. This is the language of a ghoul, Caucasian language, so spoken in the Caucasus area. This is a voice pharyngeal fricative, and you feel free to sing along.
مر
مور
مر معار
مغار
مر
م
محار
محار
مح
meh
محار
mahar. Right, this one is easier to produce because it's between two voiced vowels.
يا
Yaq,
يعار
ya'ar,
ساء
sa,
سآر
sa'ar. Right, so these here are between the two vowels, and these here are not, right? They are at the end, so they are less observable, right? And you feel free to sing along to these. All right, the next place of articulation for us is uvular. Uvular fricatives are basically made by making a channel here, making some kind of a turbulence and channel, narrow channel between uvula and the back of the tongue by raising the tongue and maybe slightly forwarding the uvula. These are uvular fricatives, these two. This kind of a chi symbol, maybe you've seen it in math, and this is the upside down R. Peter Lanaforget says aha, 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 right? This one is more difficult to make and not make it a uvular trill. If you're trilling, if you have more repetitions of the uvula hitting the tongue, then you are trilling, right? So you don't want to do that. Here you just want to make a very constricted airflow, or to just want to increase the degree of constriction, right? In this case, uvular fricatives contrast with pharyngeals and glottals in Hebrew, and we have some nice examples of those. So this is the initial one.
خمية
Chemia,
حر
hor,
هم
hem,
عر
or, right? So try not to confuse these two, right? This one is
مخار
mahar,
نحار
nahar,
نهار
nahar,
نعار
nahar,
شأون
sha'on,
لخ
lach, lach,
له
lach,
له
lah,
نع
na. Yeah, you can almost not hear it at the end here, but it should be there, right? And it should be voiced, of course. All right, the next up are velar and palatal. These are easier, I guess, to produce for all of us. Velar, they are produced. Actually, I have them in my language. Velar fricatives, especially actually the voices one. H, h. There is a h in Greek as well, and h or h in Greek. Yeah, we'll show you some examples. Then for the palatal ones, you just try to make e, but you don't want to have voicing maybe in all the cases, and you want to increase a little bit your tongue. So, right, something like that. And when you want to make a voiced one, you will have right. And this is Peter Ladefoged saying
آهیا
ahya,
آیا
ahya,
خ
ha,
آغا
aha, right? So these are velar, these are palatal fricatives, and this one does sound like
آیا
yeah, right? Like yeah. Try not to confuse it with voice palatal fricative, voice palatal stop actually, and of course with the approximant. So don't do that. Also try not to confuse these two, voiceless palatal fricative and voiceless palatal stop. The voiceless palatal fricative has this kind of hook below, and please do not confuse these two, which is this one is the ram's horn as we call it. This one is just kind of a also mathematical symbol. So do not confuse these two. This one is uvular actually velar fricative, and this one is a vowel, which is a counterpart to o. So right, somewhere there. All right, these are palatal and velar fricatives, and Greek has a very nice contrast between these back ones. For example,
χέρι,
χέρι,
γέρι,
γέρι,
χώμα,
χώμα,
γόμα.
Roma. And so these are velar, palatal, and Greek has dental fricatives as well, or interdental fricatives.
Θήκη,
Thiki,
δίκη.
Diki. So call them interdental. I prefer that than dental. They are present in English too. And this is Angeliki, our professor here at the university producing these, or Angelihi. She remember her our discussion about this one, where in her name Angelihi. This one actually is realized. So it's instead of Angelihi, it's actually the voiced velar fricative Angelihi, and Angelihi, and usually the stress in Greek is on the last syllable. So Angelihi, Angeliki, something like that. Okay, I've said it too many times now. Right. These are coronal fricatives, meaning frontal fricatives, right? We'll learn more about them in our next class, but these are postal alveolar ones.
آشا
Asha,
آژا
Aja, and these are retroflex ones. So trying to sing and sh at the same time, or and s, or and z, right?
آشا
Arsha, actually, sorry, and j,
آژا
Arsha. So
آشا
Arsha,
آژا
Arja. And many of you had problems with the nasal retroflex, right? The nasal retroflex should also be produced in that way, as if you were trying to say and n, but you're not producing so you're saying n, n, n. And this curly thing here, hook to the right, is what always indicates retroflexion. So it will always indicate a retroflex sound. That's how you can observe it or notice it out there. Next time we will look in detail at how coronal fricatives are produced in English, Chinese, and Polish. Polish has some very interesting fricatives, right? And in my name you have now you can produce it, right? Do I think we produce this one actually, Dushan, and a vowel that is characteristic of a five vowel system, right? So Dushan would be my name, and you can try to produce it. Some people produce it like this, but very rarely. Dushan, right? So yeah, now you can produce my name at least, right? Okay, the fricatives in Toda or Toda are very interesting because there is a lot of contrast in there. So
Pov,
this is pov,
Poth,
poth,
Kos,
cos. So it's a little bit towards, it's dental, right? Towards the front.
Posh,
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 Porsche is as if you're saying Porsche.
Poch,
Poch, right? Toda is spoken in southern India, and we've talked about their retroflex stops. Remember, t and okay. These are Toda mid-sagittal diagrams of cos,
Kos,
cos, posh,
Posh,
posh, right? It's quite to the front, almost alveolar.
Posh,
Porsche, right? You're curling your back, you're curling your tongue towards the back and producing Porsche, as if you're producing Porsche, a car, right? A type of car. The bilabial fricatives are the following. So these are first of all labiodental fricatives, and we know about them. They come for free.
Fa,
F and V,
va,
right? And these are
va,
V and H,
fa,
as if you try to produce them by blowing through your mouth and just obstructing the airflow. H, 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 v, v, v. I'm producing vowels, so it sounds maybe that the one that both are voiced, but they're not. So the first one should be voiceless. V, 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 right? Something like that. And bilabial fricatives exist allophonically in some languages. In Spanish, so in Spanish, cerveza, for example, I think cabeza. So that would be this one, I think, and lots of examples. Spanish really uses them, and Peninsular Spanish especially. But as contrastively, they were not recognized until recently, quite recently, 70s, 80s. It was discovered that they contrasted with labiodental fricatives in Ewe, a language spoken in Ghana. Actually, Ewe, in its name, has this bilabial voiced fricative. And here are Ewe contrast bilabial fricatives and labiodental fricatives. But yeah.
effa,
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 eve,
ewe,
eve,
eve,
efle,
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 evlo,
evro,
evlo,
evlo. Right, so these bilabial ones try to round your lips a little bit for those and obstruct the airflow. Okay, what makes a fricative, right? Well, I'll play like this. So for fricatives, turbulence is generated. So there is some kind of turbulence, a lot of air coming out, by forcing a stream of air at high velocity, at high speed, right, through either a narrow channel in the vocal tract or against an obstacle in the vocal tract. And you can think of that as, for example, let me try to draw. You can think of these as narrow channels, so some kind of narrow channel, right? And through this narrow channel, the air is coming out, right? Air, and then it's coming out into atmosphere, right, where there is a constant pressure, some kind of atmospheric pressure. So the airflow of the narrow channel would look like this, and the obstacle or the airflow of the obstacle would look something like this, right? Where you have air flowing through your channel, and then some air, gets through very easily or quickly, but some other particles or molecules of air need some more effort to go through, right? And that's why this obstacle channel is usually louder, right? So channel turbulence is produced when airflow escapes from a narrow channel and hits inert outside air, right? But obstacle turbulence, and you should be aware of both of these, is produced when airflow hits an obstacle in its path. So some kind of channel turbulence would be here, right? And obstacle turbulence is this one, and this obstacle turbulence is what increases the intensity of a fricative. So, for example, when you're producing for your s, you have some kind of narrow channel, right? Where the airflow is going through. You're narrowing the channel with your tongue. S. But you have also your teeth in front. Okay, green teeth. So we have teeth here, right? S. And teeth will make it the obstacle turbulence, right? Obstacle, which further means that when getting out, right, into the inert air, atmospheric air, it will the intensity will be higher, right? The loudness will be increased intensity, because a lot of air is rushing through your mouth in greater speed. Okay, and that's what creates the larger, higher intensity. In comparison to maybe sh is also quite loud, z as well. But in comparison to f, for example, f will be less loud, and even less loud. So this f will be louder than this one. Why is that so? Well, when you think about it, for f, you are doing several things, right? So you are touching with your teeth, upper teeth, right? You're placing your lower lip, right? Let's say this is a lower lip that is touching your teeth. But there is also the upper lip here, and the upper lip is what this upper lip is what makes the obstacle, right? And if you do this with your upper lip, you will notice how the intensity lowers when you are curling up your upper lip above and not making it an obstacle anymore. And this obstacle turbulence is what makes intensity higher. And those sounds are often louder, right? So this f is louder than h. Right? So the general rule of thumb is obstacle turbulence is much noisier than channel turbulence. Also, obstacle turbulence is louder the more perpendicular the obstacle is to the airflow. So, for example, s and h, meaning that if you make such a constriction that creates certain kind of a pathway, like then it will create such a rush of air that will run into the obstacle that will produce louder noise or much more noise than h, 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 for example, which is called in your book a wall fricative.
χώμα,
Homa, just because it's creating some kind of a wall at the back of your tongue. So voice fricatives are, of course, harder to make. In fact, fricatives are kind of hard to make in general. Fricatives require great articulatory precision. It is necessary to create a narrow channel through which air can flow. So narrow channel and hold it, right? And hold this narrow channel. And that's why it's quite difficult for children to acquire fricatives. They acquire them later than stops, for example. They first say mama, baba, tata, right? And then say s and sh and j, right? And those sounds. So these controlled articulations are much harder because you have to control the articulator. You have to place it towards the roof of the mouth, for example, and you control it. It has to be there. You have to sustain it. That's more difficult than you just go raise your tongue and hit it and go back with your tongue, like right? That's much more difficult. This is some data for S, some X-ray data. When these are alveolar constrictions are very small. These are 1 millimeter, and incisor constriction 2 to 3 millimeters. Larger constriction sizes result in sh-like sounds, right? So sh, 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 sh. Yeah, if you have a larger constriction, right, rather than lower one. Also, voice fricatives are even more difficult. And why is that so? That's a question for you to answer in our next, and I will try to answer it in our next lesson. But it's a thought question for you to think about. Okay, that will be all for now. Think about these points here, especially, right? Why is larger constriction size? Why does it result in sh-like sounds? And why voice fricatives are even more difficult to produce? All right. Thank you very much and see you soon.